Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this tutorial, I am going to be discussing about the blood cell detections and also count of the blood cell using YOLOv10. So this is the demo application. So what I'm going to do, I'm simply going to click on here to upload one images. So let's select this one and click on open and our image is loaded. If I clicking on the submit button and inside the sections, you can see here the annotated images with the bounding boxes and also the detection count. I mean, how many red blood cell or the white blood cell, neutrophil or the platinate are actually detected. So you can see red blood cell is nothing but 21, white blood cell, I mean WBC is nothing but 1, and platinate is nothing but the 1. Okay, you can also download these images from here also. So in this tutorial, we're simply going to building this one from the scratch. So बिना किसी तरह के हर हर महादेव बोल के start करते tutorial. So this is the official GitHub repository for the YOLOv10, and if I go down, then you can see here one graph based on the YOLO version 10. Okay. Again, if I go down and you can see here one tag called performance, and inside these sections you can see here some pre-trained model are available, just like YOLOv10N, S, M, B, L, X. Those are nothing but the models, pre-trained model based on the COCO dataset, which are having more than 80, just like the 80 classes. And using this YOLOv10N, we're simply going to train one custom model using this YOLOv10 architectures. So let's go on the Google Colab. But before that, we need to also checking this which kind of data set you're going to be using it here. Well, so this is our data set from the RoboFlow. That's called the blood cell detections. And using this data set, what I can do, we're simply going to building here our custom observation model and try to test it out and also count the blood cell. I mean, how many blood cells are available, just like the red blood cell or the white blood cell or the neutrophil, like that. So now what I can do, we're simply going to go on our Google Colab. Well, so right now we are in Google Colab and I rename here my Google Colab file. It's called blood cell count, and I also changing my runtime type in the form of the GPU. And you can see here T4 GPU is connected right now. So now what I'm going to do, I'm simply going to do the coding part here. If you want to do this same process in your local machines, so you should install here Python 3.8, I mean up to Python 3.8, and also the PyTorch version should be greater than 1.8 with having the CODA. So now what I'm going to do, first I'm going to installing here my library which is required for building here the custom object detection model using the YOLOv10. So for that I can using here pip install in a folder queue, and I'm going to install it from my GitHub repository, not mine actually, the official GitHub repository for the YOLOv10. So what I can do, I'm simply going to copy it from here. Let's copy it. This is the link for YOLOv10. So let's go on the Google Colab, and I'm simply going to using the git plus and the link. So shift enter. You can also using here this button for running these shells, and then we're simply going to downloading the model file. So if I go inside that, just to wait, so you can see here it having 1 2 3 4 5 6, it just having 6 pre-trained model. So you can choose one of them and try to downloading one it from here in your Google Colab sessions. So I'm simply going to download it, this one YOLOv10N. So this one, for that what I can do, I simply going to using here wget, okay, wget, and simply going to using here the capital P and Q in the same folder directory. And after that I'm simply going to giving here my link. So my link is saved on here, just to wait. Okay, so that's my link. I'm simply going to copy it from here and I'm simply going to paste it here. Okay, so one more thing, you can see it also installing here the ultralytics library which is required for the object detections. Okay, right after the YOLOv8. Okay, so let's use here the shift enter, and it will also downloading this model file in my working directory, and you can see it will downloading this model file called YOLOv10n.pt. Okay, so pt means is nothing but require the PyTorch. So I told you that make sure that if you are using this one in your local machine, your Python version should be greater than 3.8, and PyTorch is needed because you have the ultralytics which one is required the PyTorch. So it's greater than 1.8 with having the CUDA. Okay, CUDA. Okay, with having the CUDA versions. So this is a requirement for your local PC. So I don't have it in my PC. If I go to checking this out, let's open here CMD and type here Pythons. Then you can see I have Python version 3.8. Yeah, it's greater or equal, but not torch. So let's say import torch. Okay, so my torch is going to loading it here, And after that, I can checking it just like torch dot underscore underscore versions. Okay, so it's giving some warnings. So let's say torch dot underscore underscore versions. Okay, and you can see I have the torch version nothing but 1.7.0, and Coda version is nothing but 10.1. Am I using the NVIDIA? Okay, and Core i5 laptop. Okay, so that's why it's not supported in my case. So that's why I'm choosing the Google Colab one. Okay, well, now what I can do, I'm simply going to download the dataset. Okay, for download the dataset, we need to go on my RuboFlow, the RuboFlow website, and this is my dataset. And if I go inside this overview sections, then you can see inside this URL sections, inside the URL sections, it having one URL with having the project name and also the workspace name. So this workspace name is nothing but college BTJ9F, and this is nothing but my project name. Okay, so I'm going to copy this one. I'm going to copy this one. Then after that, what I can do, I am simply going to import here RuboFlow. But before that, you need to also installing this library called RuboFlow. So what I can do, I can use it. Let's say pip install. Okay, and in the same folder that's called underscore q, and I'm going to installing here the RuboFlow. That's it. Okay, so you're installing this RuboFlow library on the system. You can also downloading the dataset manually, and you can upload in a Google Drive also. Okay, then you can actually access it using Google.mount, and simply you can use the dataset here. But you can using here another technique, just like using the API key and try to extracting the data set in your RuboFlow website, and you can store it in these sessions. Okay, now what I can do, I am simply going to import it. So let's import RuboFlow. Okay, and import RuboFlow. That's it. Okay, now I need to create an instance of that called RuboFlow, and inside that you need to giving your API key. Okay, I will paste it later on just to wait. So let's say RF. That's my RuboFlow. And now what I can do, I need to creating here one workspace. So let's say rf dot workspace. Okay, and inside that I'm going to pasting here my workspace name. So this is my workspace name, CLGBT, college BTJ9F. This is my workspace name. And what is my project name? So I need to pass it like that, project. And inside this project, I'm going to giving here my blood cell detections, BSBN, this one. I'm simply going to cut it here and paste it here. So that's my workspace name, and this is my project name. Okay, so let's store the variable called project. Well, now I can download the dataset, which version. So let's say project dot version. Okay, and it's available. Let's say if I go on here, if I go inside this dataset, this is the version number 4. So you can download any of the version from here. So let's download the third versions. You can also installing here the version number 4. It's up to you, and make it version. Okay, now this version I'm going to installing it here. So let's say version dot download, and after that I can using here the version. Okay, so it actually you can pass it here YOLOv8. You can also pass it YOLOv9 also. Okay, all the data set are quite similar, but YOLOv10 is right now the newer versions. So that's why this kind of dataset version is not available in the RuboFlow. So we can take it the YOLOv8 and we can using it here on that. Okay, for training our models. So let's make it data set. So not here, we can make it call data set. Okay, version.download. So now here we can get here the API key. So you can get your API key in your RuboFlow website. So for that you need to create one account on that. Okay, so this is my API key. I can copy this one. Yeah, this is my account, and inside the section you can see API keys. Okay, fine. Now what I can do, I am simply going to go on here and I'm going to paste it here. Okay, that's my API key. So I'm going to using here the shift enter, and it will download this data set from the RuboFlow website in the from the YOLOv8, and it is storing this data set in these sections. If I go inside these queue sections, then you can see it having the YOLOv10.and.pt. This is the model file, and also you can see installing all of the library, so all of the data set, and it will also extracting it here. Again, refresh, then you can see here it having the data set. Okay, so now what I can do, I'm simply going to go on my data.yml file, and I need to do some changes on that. Okay, fine. So I need to go on this test folder, and I need to copy this images path, copy path, and I'm going to paste it here, paste it here. And same thing for train, copy the images path, and after that I can simply going to paste it here. Okay, I just need to go on here. Okay, let's close it now first, and let's open it again. Okay, yeah, here is it. I need to paste it here. So for that, I need to also delete this one, the existing one, and going to paste it here. Same thing for the validations. I'm going to copy the images path, and after that I'm simply going to uh, open it again, and I can pass it here my validations images path. Okay, so to save it now, Control S. You can use the Control S also on your keyboard. And now let's close it. If you want to checking this out again, then you can also checking this one. Yeah, here you go. Now what I can do is time to do the training part. Okay, so what you can do, let's close it, yeah, close it. Now we can using here YOLO B10N model, the P10 model for the training part. So let's say using here the YOLO, here you go, here you go. Let's say YOLO, not YOLO, actually YOLO. And task is nothing but the detect. You need to detecting here. If it is classification task, you can also giving here the classifications. Then mode is nothing but train mode. And after that, I'm giving here the epochs. So epochs is nothing but, let's say 25 epochs. And also let's giving here the batch size. So batch size. So batch you can giving here 32 batch. And let's make it the floats. If you need the floats, so let's make it the floats should be the true. And let's go on the next line. Let's say more or model. Okay, so model. Okay, so model equal to, okay, model equal to, let's say our model. So which one is from here? So I can copy this one, copy path, and let's paste it inside the sections. And let's go to the next line. Let's say data is nothing but coming from my data.yml file. Okay, I can copy this one, I can copy the path and simply paste it here. Okay, that's it. See, YOLO tax is nothing but the detect, mode is train mode, then epoch is 25, base 32, float equal to true, and then we're simply going to paste here our model file, model equal to our model file, the pretend model file, then data is nothing but coming from this data.yml file. So now we're simply going to using here the shift enter, and it will loading this data set, and also try to building here the machine learning model, I mean custom observation model, and try to do the training part here. Okay, then you can see the ultralytics one, how many parameters are available on that. Okay, and after that you can see just to wait, it will checking the training path, the testing path, and so the validations path, and now it is starting the training part here. Okay, just to wait it, I hope so it will starting the execution for the epochs. It will initialize here the optimizers. Okay, optimizer is nothing but Adam W is also giving here the learning rate. The momentum is 0.9. So soon it will actually start the epoch. Okay, well, so you can see here our epoch is starting. So now what I can do, I will back right after when the epoch is done. So well, so our training is completed, and after 25 epochs we got here our pt file, I mean my model file. So if I go inside my runs folder, then you have the detect, then you have the train, and inside this weight file we have our weight. Okay, best.pt, just copy this path. Then what I can do, I need to testing it out here. So for that I need to installing, so I'm not installing, I need to import it here. Let's ultralytics. So ultralytics, I'm simply going to importing here the YOLO B10s. Okay, that's a YOLO B10. And after that I can creating here one instance of the YOLO B10s, YOLO B10s, and inside that I'm going to giving him my model path. So let's initialize it here. Let's say model underscore path equal to this one, my model path. Fine, that's my best.pt. Okay, so that's my model. So let's make it model. Yeah, now what I can do, I'm simply going to using here model, and inside that I need to giving here my source. So let's giving here one images from our data sets. So let's go on the test images. So let's taking this one, copy path, and after that I'm simply going to paste it here. That's my images. Well, okay, we can giving here a full path because we need the predictions. Yeah, we can test it in a single images using the same method. So let's giving here the confidence score. So let's say confidence equal to 25%. Let's make in the save equal to true so that it can save it inside a folder. Okay, so it will go inside this folder. Yeah, it's the test folder. I need to go it inside my validation folder. So let's go on here, copy path, and inside that I'm simply going to pass it here. Okay, that's my validations one. Fine. So you can see here it having the 94 images. Yeah, so it will save it inside my run, detect, and predict to this folder. So what I can do, I am simply going to show these ones. Okay, that's my model file. You can see quite long. Okay, it's the predictions for the each of the images. So each of the images, it actually give me the predictions. Okay, so now what I can do is simply going to using the matplotlib so that we can show you this one uh, just like a float. So to save it inside my run detect predict to folder. So what I can do, I'm simply going to first importing the globe so that I can taking all the images from this predictor folder, and I can creating one batch of the images and show it just like a subplot. So for that, and it also importing here the matplotlib. So matplotlib dot pyplot, okay, pyplot as plt. Then I need to also importing here matplotlib dot images dot image as mp image so that I can show this one, right? Now what I can do, I'm simply going to taking all of the images from my predictive folder, because inside this predictive folder I having all of the images with the predictions. So if I go inside this runs folder, detect, and the predictive, then I have some images. If I opening this one, then you can see it also detecting here my blood cell. Okay, so WBC, the white blood cell, the RBC, red blood cell. Okay, cool. So let's close all tabs. Okay, now what I can do, I'm simply going to creating here one globe objects, and inside that I need to giving here my folder path. Okay, I'm simply go on here, runs, then we have the detect, then the predict to, then after that I'm going to copy this one, copy path. Okay, copy path, and now inside this from the predict folder I'm simply going to taking all of the images, which one is starting, who's not starting actually, which one and with the jpg. Okay, because all of the images are in the form of the jpg format. Okay, so let's take all the images from here using globe. So that's my images. Okay, and then I'm simply going to display the images. So let's display here the 10 images from each of the folder, I mean in the folder. So I can using here, let's say images to display, display, then I can using it here, let's say display equal to, let's taking the 10 images from our directory. So let's taking the first 10 images. So you can also using here the random function for taking it randomly. Then we're simply going to creating here on subplots. So let's say subplot, where we're simply going to plotting here our 10 images. So subplots, so let's say 2 comma 5, that's been 2 row and the 5 of the are the columns, and each of the column it having the images. So let's giving here the fixed size, I mean my figure size is nothing but 20 comma 10. It's a hit and trial. Let's make it inside the fig and the axis. Okay, now in the x-axis I am simply going to show my figure. So for figure and show the figure, we can enumerate it just like my count of my images and also my axis. Okay, so let's say for I or x in enumerate. Okay, enumerate, and I'm simply going to passing here my axis dot flat. Okay, axis dot flat. So which will give me one flat of my axis, I mean 10 of that. Okay, that's mean it having the 2 row and the 5 columns. To creating one flat of that, and it will give me the axis with having the id. Now what I can do, I'm simply going to checking that if the length, if the I is less than equal to length of the image to display, that's mean how many images should be displayed. That's a 10 images should be displayed. So that's why I need to checking this one so that I can give here on bracket statement or if or else condition so that I can show it in just like a row and the columns. Okay. Now after that I can show it just like image equal to np image that we import it dot imread. Okay, imread. So we're simply going to read it based on image to display. I mean, which one we simply going to display based on the index number. That's a 0, 1, 2, 3, 4 like that. It will be reading it based on the image to be displayed. I mean, 10 images should be displayed on here. Then after that, I can using here ax.imshow. In the axis, I am simply going to show my images. So which images? These images. Okay. Otherwise, if there are any error or otherwise, so we're simply going to making my axis should be off. Okay, axis should be off. So we can copy these ones. Also, we don't need the axes to be printed. So that's why I'm going to making it axis equal to off. Okay, fine. Now let's making it plt.tight layout so that it's low but tight. The layout should be in front of the tight layout, and we can simply using the plt.show. That's it. Okay, so that's the code, and it will taking all the images from this predictive folder and display the 10 images just like the row and the columns, and with having the detections. Well, so just to wait for a few seconds and it will try to do that. Now it's time to detect the single images with how many red blood cell or how many white blood cell or the neutrophils are available. Now you can see here, this is the images. See how cool it is detecting all of the images, and you can see, okay, white blood cell. Okay, you can see cool white blood cell, the red blood cell, white blood cells, and it's also having the neutrophil or the plates. Okay, you can see that is okay. Okay, platelet. Okay, so that's it. This is how it actually work. So you can simply going to count in this one. Okay, so what I can do for that, let's taking the first taking one simple images, single images. Then what I can do, we can going to checking this one, how many RBC is detected, how many WBC is detected. Okay, or the neutrophil or the platelet is detected. Okay, so for that you can using here model lot predict, and after that you need to giving here my source. So let's say source equal to nothing but one images. So let's taking the images from the validation folder, or you can also take it from the test folder also. So let's taking one images. So let's taking the first images, copy the path, and let's close it, and simply I'm going to paste it here. So this is my single images, because you need to also creating here our web application, right? So let's giving here the image size. So that should be the image size is nothing but 640. Okay, that's our image size. And after that I need to giving here the confidence score. So it's will nf equal to 0.25%. Okay, that's our confidence score. Okay, now what I need to do, मुझे यहाँ पर थोड़ा इधर पे जाना है. Okay, so that's my model. Okay, predictions. So let's make it, let's say result. Okay, that's my prediction results. Now what I can do, I'm simply going to plot it, my result. So result.plot. Okay, result.plot. Okay, so which one? The first index one. Okay, result 0 dot plot. So this is my annotated images. So let's say annotated image. Okay, that's my annotated image. I mean, this having the annotations, I mean the bounding boxes. It's also called a BB blocks. Fine. Now after that, I need to take in the detections, and also we need to counting that how many RBCs detected, how many WBCs detected, or how many neutrophil or the platelet are detected. Okay, so for that I need to creating here one another variable called detections, and I'm simply going to making it from the results. So let's say result of the 0, and then from the result of 0, and I need to take in the boxes. I mean how many boxes is detected, and with the data. Now what I can do, we need to getting also the class name. Now we count that how many boxes are detected in the each of the folder, so each of the images. Now we need to checking that which box is detected with having the class name. So let's say class name. Okay, class names equal to, let's take it for model dot names. Okay, dot names, and from that I need to taking the class names. So let's making it, let's say class, and I'm simply going to using here for loop. So let's say class in detection. Okay, detections with having the class name. How many class names it have? So it having maybe 4 class names. So let's making it 5. Okay. So you can also give it here 4. It's having the 4 class names that you see in our data set. Okay. Just like the white blood cell, the red blood cell, and also the platinate, and also the platinate, and also the neutrophils. So that's mean 4 classes. Okay. So let's taking the class name from here. Okay. So it's having the 0 to 5. So let's take it from here. It should be the integers. Yeah, right now, okay. Integer class for classes from the detections. So that should be the detections. Okay, it's from the detections. Yeah. So this is my nothing but class names. Okay. So I can also check in this class name also. So for counting this one, we can using here the counter. So that's the counter. And inside this counter, I can pass in here my class names. Okay. Let's make it, let's count. Okay. So this is my counter. And inside this counter, what I can do, I'm simply going to pass in here my class name. Okay. So now for getting the string name, so what I can do, we can using here the join functions for taking this out. But before that, let's try to printing here my class name. Okay. So let's say this is my images. So let's print here the class name. So this is my class name. Just to write. You can see, yeah, you can see the class name RBC, 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 WBC. This is the class name and also the platelets. Okay. Okay. That's mean how many classes are available on that. So now what I can do, I can simply go into using here the counter for actually counting the how many classes are actually detected here. Okay. So let's making it like that counter, and inside this counter, I am simply going to passing here my class name, and after that, let's try to do the detection part here. Okay. So let's say detection string. So let's take in the detection string from the all of the class name. So for that, I can using here one comma. Okay, comma. That simply I'm going to join it here. Let's say join, and inside that I can passing here on f string. So let's say just passing here on f string. That's mean this is the name called RBC, and this is the count number. Just like nothing but a detection string. That this is the RBC, and those are the RBCs detected, just like that. Okay, that's nothing but you can also taking it as a string. Okay, let's create one f string. Let's say name. Okay, this is the name, and let's making it also count here. Okay, so let's making it count like that. Okay, this is the count. So this count is taking from here from name, and the count is coming from my class name. So let's say count in count.item. So count.item. So this one coming from this count. Okay, so let's making it items. Okay, this is the items. So our detection string is ready, so we can print it out. Let's call detection string. So the detection string is nothing but like that. It will taking all of the item from this count, because this count is coming from this class names, and from these items it will having the name, name, and also the count, just like the hash map in the C++ or DSA. Okay, we need to also importing here the counter from the collections. So let's say from collections, it's nothing but call the Python collections. From collections, you're going to importing here the counter. Okay, so our counter is also imported. So that's my detection string, just like RBC, how many RBC it have. Then we can also using here the annotated images, so that we can also showing the annotated images also. So let's say the row, the column, and also the last of that, and let's make it -1. Okay, now we can show our annotated images also. Okay, so let's run it out and try to checking this out for the predictions. Okay, you can see here the images, annotated images, and how many RBC, how many WBC, and how many platinate are actually available on here. Okay, so now we can using it here, this same code for creating the web applications. So for creating the web applications, we're going to using here the Gradle library. Okay, so let's try to using here the Gradle library. So for that, I need to also installing this library. So let's say pip install Gradle. Okay, you can also using here the /q if you wanted to installing this same library in this folder. So I don't think that I need it. Okay, yeah, if you need it, you can also using here the same technique. So now what I can do, I am simply going to loading here the Gradle library. So for that, I'm going to importing here, let's say import Gradle as gr. Then I'm going to importing here the cb2. because I need to convert you the images in the form of BGR to RGB, because this is the RGB images that we see on here, RGB images. So that's why I'm not also changing this one. Okay. Then after that, what I can do, I am going to importing here the numpy. Let's say numpy s and p. Okay. You can also importing here the collections. From collections, we can importing here the counter as well as. Okay. So counter. Okay, fine. Okay, that's our counter. So now what I can do, we simply going to creating here one function called predict, which on taking one images. Okay, that's my images. So I am simply going to copy the, I can simply going to copy this one, just a wait. I can copy the same code as well as from here. And after that, what I can do, I just need to do some changes on that. Okay, I'm simply going to pass it here. This result, this annotated image, the detections, the class name, the counter, the detection string, the print, annotations, images also. So now first thing first, I need to loading the images in the form of BGRs, and also I need to convert them in the form of the RGB. Okay, so our image is already loaded because we have the image path name. So what I can do, we can simply going to using here cb2 dot cbt color, and inside that I have to giving him my image. And because cb2 read the images in the form of the bgr format, I mean blue, green and red channels, so I need to convert them in the form of rgb, red, blue and red, green and the blue. Okay, so let's give it here the images, these are our images. Okay, we already give it out, just you need to give me here the code called cb2 dot color. Okay, color bgr2 rgb. Okay, that's the color code. Okay, so this is nothing but my image. Okay, this is nothing but an image rgb format. Okay, so now I can copy these ones and I can simply go into paste it inside my images. Okay, this path. Okay, so this is my image rgb and our image size is nothing but 640, and that's my annotated images plot, and that's my annotated images. Okay, annotated images, and also my counter, it also having the counter. So now what I can do, I am simply going to, instead of printing, I am simply going to return it here. Okay, let's say return here my detection string. Okay, that's my detection string, and also also going to give it here my annotations images also. Okay, so this my two data, I can get it from here called annotation images, and also my detection string, right? So I can removing this one from here. Okay, now what I can do, I am simply going to yeah, why I actually delete it, I need it here, this annotation images, and let's making it the same variable name called annotated images. Okay, so annotated images equal to these images, and also having the detection string that you know to actually return it here. Now using this one, we can creating one interface for the Gradeo library, and after that I can show it in a applications. Okay, so for that I can creating here on app. So let's say app equal to gr.interface. Okay, interface, and inside this interface I can passing here my function called predict, and after that I can giving here my input. Okay, that's my inputs, it's nothing but a gr.image, so I can upload the images from my directory. And after that you need to giving him a type, so that's a type is nothing but a numpy. Okay, numpy type. Okay, because image is nothing but one numpy array, multi-dimensional array. So let's giving here one label, so you can giving here label call, let's upload an image. Okay, like upload an image. Okay, so same thing what I can do, we can using it here for the outputs. So I can copy this one and I can give it here. So this is also the same thing for the images, but it just having one extra thing called counting. Okay, call counting. So you need to giving here one list. So this should be the output first. So outputs. Okay, outputs. Okay, outputs, and just having one list, which one having the output. So it should be the annotated images. So let's say annotated image, the label uh, for the images, and then we have the counter. Okay, so let's say gr dot text box. Okay, we have one text box, so we can using here the text box, and after that inside this text box I can giving here one label. So label is nothing but my detection count. Okay, that's my detection count, detection call count. Okay, that's the counts. Okay, CUNTS, detection counts. Okay, fine. Okay, now what I can do is simply going to give it inside one list. So the same list we can give it here, gr.images, and type is nothing but the numpy array. And after that we have the label is nothing but called annotated images, and also having gr.text box, and label is nothing but the detection count. Cool. Okay, so now what you can do, I need to also giving here one title. So let's giving here titles. So let's say title is nothing but, let's say, blurred cell count. Okay, using YOLOv10. Okay, you can also giving here one descriptions. Okay, description, let's give it here description. You can give it here, let's say blurred cell. Okay, for the description, let's not blur exactly, let's say upload an image. Okay, let's say image, and the YOLOv10 model with detect. Okay, will detect and annotate blood cell. Okay, fine. Now what you can do, we can using this one, and after that we can using here app.run. Okay, app.not run, actually app.launch. Okay, launch. Okay, launch. Okay, so I think my runtime is also disconnected, so let's disconnect it again. I think my internet connection is lost. Okay, so what I can do, let's connect it again and try to run in this code. So now it's time to run the code, and I also connect it here. So let's run this out. So let's using the shift enter, and we have one error. So okay, this should be the text box. Okay, just like that. So now I hope so. Yeah, you can see our application is right now in the live. So you can click on this link. Okay, otherwise you can also go on the Google Colab, the same things in the sequences. You can see it's also loading. You can also test it out from here. So let's go on the another skins. You can just clicking on this link, and it will also loading your applications in another screens. So you can also share with your friends, just like the links. So let's click on here and choose one images. So let's say from the testing, let's choose images, and I'm simply going to click here to submit. Okay, let's click on submit. Okay, so now you can see it detected. That's red blood cell is nothing but 23, white blood cell is nothing but 1. Okay, let's clear it again, and let's start uploading here another images. So this is the version number 4. Okay, this data set is nothing but the version number 4. So that's why I downloaded the version number 3 and testing the data with the version number 4. This is completely the unseen data, completely unseen data. Okay, so let's see how for the unseen data it will working. Okay, and you can see 26 platinate is nothing but the 1, the WBC. Okay, it's nothing but call the 1. Okay, that's been how cool it will actually detecting the blood cell for the new data also. Okay, let's try to upload here one scene data also, and that actually download it here. So let's download it, select it here. This is my own dataset images. So let's click on submit. Then you can see how many red blood cell and the white blood cell or the platelets are actually detected. Okay, so this is how the application is look like and how it is actually detected. You can also downloading this one, this annotations one. So that's it for today now. Hope you enjoyed this tutorial, and make sure to subscribe to our channels and also support the knowledge doctor so that we can grow just like the 50K. Okay, so thank you and bye bye.